Hello, my name is Isabel Sagar, and for this video I will be discussing imperfections in solids. Imperfections in solids can also be known as defects in solids or deviations in solids. So for crystals, crystal deviations will also be known as crystal defects. These imperfections in solids are present in crystals and metals. Not all crystals or solids are created equal. Their imperfections are what make them so unique. Imperfections in solids are what leads to other important properties of the materials. Now, these are the three types of imperfections in solids that I'm mentioning: point defects, line defects, and area defects. The point defects are vacancy atoms, interstitial atoms, and self-interstitial atoms, and substitutional atoms. For line defects, there are dislocations, and for area defects, there are grain boundaries. These are the point defects that I will be focusing on for my 3D model. Now, what is a point defect? A point defect is a defect that affects the nearby atoms or lattice points in an atomic structure. A point defect can be clearly seen if you look at an atomic structure. The types of point defects that will be showcased in my 3D model are self-interstitial atoms, and what those is a defect in which more atoms are present in between atomic sites. Vacancy atom, which is a defect in which there are vacant atomic sites in the structure. And interstitial atom, which is a defect in which a similar type of atom is in an interstitial position in the structure. Here I include a picture that shows each of the point defects. Now, as for the substitutional impurity, I do not include this in my 3D model, but it is shown here, and you can see that it is a different color. It is in between all the other atoms. It disrupts the pattern of the atom, and that's why it is a defect. For self-interstitial atom, you will soon see this in my 3D model, and you can see that this also disrupts the pattern of the atomic structure. And the vacancy atom just means that there is no atom present, which is why it is vacant atom. And the interstitial atom here, which is also a different color, so it could be a different element, a different atom in the structure, and it is a different size. So now I will showcase my 3D model that includes those 3 point defects that I mentioned previously. So here is my 3D model, and right off the bat you can see that the first defect that is shown here is the interstitial model, which are these atoms here that are right in the middle of the other atoms. As we go to the other face of my 3D model, you can see that the ones here in the middle are the self-interstitial models, because it is the same atom that are just placed in between all the other atoms, but it disrupts the pattern of the whole atomic structure. And as I go to the other side, you can see that the pattern here is not disrupted by other atoms being morphed together like how it is on this side. Now, the last defect that I showcase here in my model is a vacant atom, which is clearly shown here that there is no atom present, and that is a defect in this 3D model. And I will go around here so you can see all perspectives of my 3D model. And that is all. Let me know if you have any questions. Thank you.